grade 12 mindsetters. This is physical science for you guys. I'm Katleho, and this is Phil. Phil, welcome. How are you?
I'm great, thanks, Katleho.
Good. What are we going to be doing today?
Well, we're going to be doing a little bit of a whirlwind chemistry revision. I thought I'd hammer the students with a little bit of revision.
Okay.
What we're going to be doing is posting a couple of past paper questions online. I'm going to be giving you one of those horrible, nasty challenge questions, and I hope you guys are going to discuss nicely. But yeah, that's about it.
I know you guys will enjoy that because exams are now and you guys need all the revision you can get. So thank you for all that revision. I'm going to tell them about the Facebook page. You can walk over and prepare some details. Remember that our Facebook page, facebook.com/learnextra, and our Twitter handle is @learnextra. During the show, you can send in all your questions and queries on what we'll be doing, chemistry revision. Thank you to Liberty for bringing us this awesome show. And we also have the calculator for you guys. Casio calculator and the Casio labeler. So remember to send in all your questions. I know you grade 12s are very interactive, so it's not hard for us to choose a winner out of you guys. So keep with us the entire show. And in the last 15 minutes, Phil will be answering your questions on what we've been doing. Over to you, Phil.
Thanks so much, Katleho. All right, well, grade 12s, what I've decided to do is to break it down. What we're doing is we're breaking down your chemistry exam. We're trying to see what's inside there, what's important, what's not. And what I'm actually going to do is I'm going to take a look through your chemistry and what's expected in the exams. And the way that I've done this is according to the subject assessment guidelines and the last 3 years' papers. So towards the middle part of this show, I'm actually going to be running you through a whole bunch of multiple choice questions, because they cover the entire chemistry syllabus and they pull together all your skills. So I just wanted to run through what you should be studying, what you shouldn't be studying, because you're probably sitting there with the textbook in front of you going, I have no idea where to start and what is important. Okay, so what I've decided to do is actually to break down most of your chemistry papers, paper 2 for those of you that don't know, and we're going to take a look and see which sections are that important. Okay. So first of all, what we're going to be doing is I'm going to be going through a very basic breakdown of all 3 the major sections. Okay, so I've gone and seen that organic molecules. Now, this one can change anywhere. Now, I've written down 35 to 40, but I've noticed that sometimes it's as low as 30% of a paper, but it's a very sizable chunk of chemistry. Now, the reason that I point out organic molecules as something incredibly important, apart from the fact that it's 1/3 of your paper, is that organic molecules is something completely different to other types of chemistry. So, if you're one of those kids or one of those people that really doesn't like the way that chemistry was taught in grade 11 or grade 10, this is a fresh start. This is one of the ways to get your foot in the door of chemistry, because organic molecules is something, if you spend 2 or 3 days with it solid, you can actually improve your chemistry mark by a lot, because it's such a big portion of your exam. Okay, now, I've left the best part, I think, for the middle part, and that is chemical change. We're going to be breaking down chemical change. It's another round about 1/3 of your exam, and I've actually noticed that that number has been creeping up over the last few years. Chemical change is definitely one of those sections that people really struggle with, and I've noticed in the last 2 shows, from grade 10 and 11, chemical change has been a big part of their shows. That's been balancing chemical equations, calculating moles, talking about the rates of chemical reactions, equilibrium as well. So chemical change is another big piece. Now, chemical systems is something which, especially in grade 10, is not paid that much attention, but all of a sudden in grade 12, there's something which creeps in, and all of a sudden it's nearly 1/4 or almost 1/3 of my paper, and we're going to see what's important there, because chemical systems has changed a lot over the last few years. Chemical systems used to involve things like fertilizer. It doesn't anymore. So please, I want you to pay attention when we start taking a look at chemical systems, because there are some pieces which are not examinable anymore. I want to make sure that you're not studying all those materials that you actually don't need to. Okay, a lot of these industrial processes, actually you don't need to know. So chemical systems is the way that we apply the chemistry. I would advise that you start with these in this order. Okay, organic molecules, most of you have covered that. Chemical change, I've noticed from some of the questions on Facebook that you guys are really into this stuff, and we're going to pay a lot of attention to it. Chemical systems, I actually want you to leave until last, because chemical systems is all about the details, and they're the things which you forget, and they are definitely the things which are easy marks. All you've got to remember is some labels, you've got to remember some reactions. Very easy to work out if you sorted out chemical change. So do that one first. I would actually advise that you start with organic molecules, and you're aiming for a full marks in your organic molecules, because you can actually do this. Once you understand organic molecules, it's easy. And that means that you could even pass your exam. Please don't do this just by doing organic molecules on its own. So it's a fairly large section. Inside one of your textbooks, you might actually find it under a different section. It's called Matter and Materials, and that's organic molecules. Okay, so what we're going to do is, for those of you making study lists and checklists at home, I'm going to break these 3 sections up, and then we're going to work with that. But before we do that, I'm going to be putting up a majorly difficult challenge question. And here it is. Okay. Now, this is slightly different to any challenge question which I've posted before. I've started to take a look at a little bit of organic chemistry, a little bit of chemical change. I've actually decided to include them all in one question, because I'm mean and nasty and I want you guys studying all this stuff. So what I want you to identify is, what are chemicals X, Y, and Z? Okay, so let me just guide you through this flow diagram, because it looks like a lot of chemicals all in one place, and it is. I want you to see what's going on here. On the right hand side here, I've got chemical Y, which is coming in here. Let's just highlight it as we go. So chemical Y is coming in here, and I'm fairly sure if you guys are busy drawing this down with me, we're going to be posting this up to Facebook. I'm hoping that's happening. And then I've got chemical Y, which is going through electrolysis. There's some other chemicals which are coming out here. I've got sodium hydroxide. I've got some hydrogen as well coming out of that. Okay, and that should be a little bit of a clue. Okay, electrolysis giving me these 2 things. Okay, and then the last product of this electrolysis, because it gives me 3 different products. There we go, chemical X. Okay, this has nothing to do with Powerpuff Girls. Okay, and I'm not Professor X. Okay, so this is chemical X, and chemical X is one of the products. Here we go, and chemical X combined with chemical Z goes to give me this magical product over there. Okay, now this product down at the bottom here is used in dry cleaning industries. Okay, very, very dangerous stuff. Okay, now I'm going to give you a little bit of a clue. Over here, count very, very carefully, because I'm telling you now that most of you are going to get chemical Z wrong. I'm pretty sure you can get Y and X easily. Chemical Z is going to be the real challenge. Count your hydrogens, carbons, and chlorines very, very carefully, because that's where there's going to be problems. Okay, so when you post your ideas on Facebook, I want you to have a full explanation as to where you got X, Y, and Z from. Please, with their names. And also, if you're just guessing, if you're just starting to chuck out chemical names, okay, it's going to make life very difficult for Katleho over here. And also, that's going to create a bit of a problem for us. We can't give you a calculator if you're just guessing. We want you to explain it to other mindsetters as well. Okay. Well, now that that challenge question is up there, let's get right into our lesson. And there it is. Okay, so I'm breaking things down. I'm actually making study lists at the moment. And what I'm going to do is, at the end of the show, I'm actually going to post this all up on the page. So that's really no problem. You shouldn't be furiously writing. I just want you to remind yourself, okay, I know that, I don't know that, maybe I need to work on this. So I've actually summarized the pieces in each section and how to study this. Okay. So organic molecules, or matter and materials as it's called inside your textbook, the things which we need to revise. Okay, now there's a few major sections over here. The first thing that I want you to start dealing with is the language. Okay, please, organic materials, always, always, always. I say, whenever you're practicing this, go over your naming. I would spend 2 or 3 hours just going over your naming, how the IUPAC system works, why the IUPAC system works, and sit there with a page which is actually reminding you about your functional groups. Practice the naming. It should be like second nature by the time you're done with this section. Okay? Spend an entire afternoon on organic, and it's going to reward you. Okay, next, the organic reactions. This is probably the section that most people struggle with the most. So here we go. There we go, reactions. I actually want to spend a lot of time trying to figure out the patterns going on here. Now, reactions are all about studying the patterns, not trying to memorize reactions. Please, 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 don't sit and try and memorize each individual reaction. That's going to cause you grief, it's going to cause you terror, and it's going to make you cry. Okay, please. So addition, try and understand what addition is and how to recognize it without saying, okay, well, I remember that chemical. You're going to give yourself a little bit of a heartache when you're trying to do that, because there are over 29 million organic compounds to remember. There's no person in the world that can even counter that number or even remember that many compounds. Cannot do it. Look for the patterns, please. Okay, it'll make your life a lot easier if I'm looking for, okay, 1, 2, 3, 4, 5 patterns. That's really not too difficult to remember. Okay, now if you remember from earlier on in the season, okay, you can go back, way back on our page. You can actually look for that lesson where I did one on chemical reactions. It's on the learnextra.co.za, I think. And it was posted on the Facebook page, but perhaps I'm going to get Katleho to dig that out for us.
Yeah.
Okay. And then very, very lastly, but not leastly, something which comes up in your multiple choice. Here it is, the properties of organic molecules. You need to know what these words mean and how to predict them. Okay, so the boiling and the melting points. Viscosity was a weird one that we discussed here in studio. And how to predict if something is a solid, liquid, or a gas. Okay, so that was organic molecules in a nutshell. It doesn't look like much, but this should take up an entire afternoon, at least. Okay, spend a few hours. It's going to reward you. Almost 40% of some of the papers that I've looked at are organic molecules. There they are. Okay, now for the big one. Okay, now chemical change. Chemical change is the thing which causes people a lot of heartache. They say, this is why I don't enjoy chemistry. Okay, well, it helps if you break it up into tiny, tiny little pieces. Okay, so what I'm going to do is I'm going to revise the main headings that you guys need to go and revise. Okay, the rates of reactions. I would actually start with this one because it's nice. It's like baby steps. It's easy enough to get into. The rates of reactions. Now, some of the headings that you should be looking for things to revise. And I'm going to go through them very, very slowly with you, just to make sure that you can get them down and remember and see where they are. Okay? Collision theory. I've got to remember why reactions take place and how to control that. Okay, collision theory is in every single exam. Tell you a little bit of a tip. Something which comes up in every single exam, and I'm telling you this will be a question in your exam, is trying to relate the collision theory to the factors affecting the rate. So these two things are always tied together. So if you understand those two things, there's 10 marks on their way in the post to you guys. Okay, now something slightly more difficult, the graphs of these reactions. Okay, now this is to do with rates of reactions. I'm going to tell you this as well. The graph describing a rate of reaction, usually in the form of an experiment, is going to be in your paper. I can tell you this, it's going to be in your final. It's been in every single final paper. Okay, so graphs when you're doing a rate of reaction experiment. Look for those experiments in the past papers. There's always a graph involving the rate of reactions. This is the way that they understand if you can read a graph or not. Now, if your graphs are not so hot in maths, it's not exactly the same thing. If you can understand a steep or a shallow slope, that's all that you need to know for these graphs. So please don't be afraid. Baby steps. Spend a little bit of time. Again, it's going to reward you. Okay. Now, this word equilibrium, this is a swear word to most matrics. Okay. Please, please, please don't see it that way because equilibrium actually ties in very nicely with the rates of reactions. Okay. If I go and study Le Chatelier's principle, I will understand the factors affecting it, and then, only right at the end, do your KC calculations and the graphs involving equilibrium. These are just some of the headings that you should be looking to learn when you're doing your preparation for your chemistry exam. Please, please make sure that you go through all of these and, okay, right, equilibrium graphs, got them, got my KC calculations, I know who Le Chatelier is, the factors affecting. Okay, and then lastly but not leastly, here we go, redox. Okay, now a whole bunch of you have said that you don't really dig redox very much. Okay, not a big problem. Okay, what you've got to do is go and revise your grade 11 stuff. Start with the basics. Relearn what reduction and oxidation actually means. Learn your half reactions. Go back to them because you're getting marks here just for copying reactions off a sheet which you get. Okay, this is such easy marks if you know how to navigate their table. There is no excuse. If you don't know how to do redox, that means that you are not practicing. I can tell you that now. If you've been watching the last few shows, I'm not going to focus too much on redox. We've been doing a lot of it in the studio. I want you to make sure that you know how to identify and write down half reactions. Once you can do that, and only once you can do that, can you then go and do the really big stuff and go find out your E0 cell calculations, your electrochemistry cells, and eventually work your way up to the final stuff. Okay, now, before we go any further, I I just want to make sure that people actually understand that this stuff, chemical change, is actually the basis of all chemistry. If this is the section that you're battling with, then start here instead of organic chemistry. One of the things that I want to make sure that people understand is that chemical change is what chemistry is all about. It's how we make our new chemicals, and you cannot actually do the other chemistry without it. If you're really, really stuck on this, go to the organic, start there, no problem. But then organic chemistry followed closely by chemical change. You cannot do chemical systems without knowing what you do here. Because I can tell you now, they're going to show you that chemical change is one of the pieces that they ask for in chemical systems. So the two are actually tied together. You can't separate them. The only piece which is completely different is the organic chemistry. Right. And then our last section, okay, a lot of people forget about this until last, and I want you to do the same thing, is because you cannot understand any of these industries without knowing what chemical change is all about. Okay, the chloralkali industry, where we produce chlorine, hydrogen, and sodium hydroxide. Okay, you need to know about the 3 different cells and the redox involved. So you can see, there we go. We need to understand redox before we even touch the chloralkali industry. Electroplating, there it is. Redox, again. Now, electroplating is one of those things that's going to come up in one of those multiple choice questions. We're going to take a look at it a little bit later. Okay? And we need to understand some of these things. Electroplating, metals, cathodes, some terminology I need you guys to know before we go anywhere with this. Okay? Batteries, primary and secondary cells. Okay, now I can tell you to focus your studies a little bit. Make sure that you know the lead acid and the dry cell. Those are 2 things which come up in almost every paper when they're starting to talk about batteries. Okay, slightly less focus I've noticed on batteries of late. I find that they tend to ask a lot of these questions in the form of multiple choice, true or false type questions right in the beginning of your paper. Last one I've got on here is the aluminium industry. Very, very important in South Africa because it's using a lot of electricity, but we export a huge amount of aluminium. Become knowledgeable about it. Because between Mozambique and South Africa, we export thousands and thousands of tons of aluminium because we produce large amounts of electricity, and we just across the sea from Australia, and they ship us the raw materials to produce this aluminium. I'd actually advise that you Google this a little bit and find out a little bit about what a company called Alusaf does in Richards Bay. Okay, so the aluminium industry is very, very important in South Africa. But more importantly, sorry, to understand it, I need to understand redox. Okay, again, there's that word, redox. You'll notice that every single one of these is a different way of asking you chemical change. Okay, so before I get into these multiple choice questions and before I answer that challenge question, I think Katleho.
Yeah, do you want to go for
a short ad break. Yeah. I'm going to get a glass of water to get the frog out my throat.
Okay.
And then we're going to jump straight into those multiple choice questions. I've asked that they get posted up online, and you guys can actually follow. I want you guys to work with us, make sure that you're actually practicing this at home. I can tell you that you're going to learn almost nothing just by watching us. I want you guys to get involved, jump on Facebook, jump on Twitter, get involved with us, and I'm pretty sure Katleho is waiting for you.
Yeah, I really am. And remember that you can ask questions on the basics and what Phil has just gone through now. So if there is perhaps anything that you're not really getting, let us know. And if you target it from there, then it's so easy going forward. So get all your questions ready and lots of paper and lots of pens ready as well, because it's going to be an awesome show. Have a great break. See you after the break. Welcome back, grade 12s. I know that was a really quick break, but as you have noticed, Phil has posted the challenge question for today for all you guys who love a good challenge. It's a great one. So during the breaks and when you can, just grip into it and just send us everything. Send us what you don't understand about it. Send us the answer, obviously, and also help those people that you know haven't really got it. And in your explanation, perhaps you can also show how you got to your answer so that we know that the right steps have been taken just for you to understand it better. Over to you, Phil.
Thanks so much, Katleho. Okay, well, the first one that I'm going to be taking a look at is actually from a March 2010 paper. Okay, it's paper 2 if you're looking for it on the government's website or on Tutong or on our website. Okay, the March 2010 paper. Now, just a little bit of a study tip. If you want the most difficult papers out of there, I've actually noticed that the deferred examinations, the February, March papers, are always a little bit, maybe 5% more difficult than the ones which were set for November. Okay, I think it's for those guys who thought they were going to get away with it and sort of put on a bit of a sniffle. Okay, it's slightly more challenging. I found that the difficulty weighting is exactly the same, but I found that the question paper just seems a little bit more challenging. I'm not sure if it's just me. Okay, but the first one that I'm taking a look at is question 3.1. And we're going to take a look at a little bit of organic chemistry, and I want to show you just how strange the way that they ask their questions is. Okay, so we're being asked to consider a flow diagram below. So I get given some information over here. I'm told, first of all, that whatever goes into my reaction there is propene. Then they tell me that it goes through some sort of process. I've got H2 over there, and I've got PT below. Now, just a bit of a hint. Whenever you're writing something underneath there, usually that's something which is helping the reaction, or it's the conditions of the reaction. Sometimes if you write something on top, that's something which is actually chemically getting involved. Usually, at the bottom, I put things like catalysts. On top, I put other reactants sometimes. So if you see something on top, another chemical, very often it's actually just another reactant. So there's a little bit of a hint. Okay, so if you're busy studying organic chemistry, now is the time to take some notes. This one is up on Facebook as well. You guys can start commenting, discussing it if you like. Okay, so let's take a look at this. I've got propene plus H2. So I'm actually going to write H2 in as a reactant over there. So H2, propene, and I'm going to make compound X. They seem to be quite keen on this idea of having something X. Okay, I like that as well. There we go. So compound X is the product. Now, one of the problems that I find with these is that I can't actually spot what's going on. I see, okay, well, a propene, what happens to propene? Please don't try and remember the actual chemical names like I said. The reason that I chose this question was to show you how to work out patterns. Organic chemistry is very visual. You've got to see something with your eyes, and all I see here is writing. Okay, now the really cool thing, and the reason that I like organic chemistry so much, is it's all about the pictures. Okay, so what I'm going to do is I'm actually going to redraw what we've got. So H2, I'm actually going to draw this in a Cooper diagram where we actually show the bonds. So I've got hydrogen now represented there, plus propene. Okay, so let's just remind ourselves, why are we taking a look at the naming? Well, the prefix says prop. Okay, so that's 1, 2, 3 carbons. There we go, 1, 2, 3 carbons. Okay, it says ene. Ene means a double bond. There it is. Okay, now I've got to fill up everything else with hydrogen. Make sure that you've got 4 bonds for each carbon. If you've forgotten that, this should be a little bit of a revision for you. You're going to get a little bit tired of drawing in these hydrogens. I know I sure do. Okay, so there we go, some hydrogens at the end. Now, there's a bit of a clue. I've taken 2 reactants. There's my first clue. One of my reactants is unsaturated. That's telling me that I've got a double bond. So that is unsaturated. There we go. So unsaturated is our second clue. Now, I know that if 2 things go in and only 1 thing comes out, so 2 reactants in, 1 product out, also, I've got something unsaturated going in. There's 2 clues reinforcing my suspicion that this must be an addition reaction. I must be adding these 2 together. Because only 1 thing is coming out, something must have joined in between there. So I'm taking 2 pieces and I'm making them into 1. Remember what I said, spot the patterns. So when I'm looking at an addition reaction, I've got 2 reactants, 1 product. One of the reactants must be unsaturated, and there's your second hint. Okay, so when I do addition, I've got 2 hydrogens joining on there. What we're going to find is that a saturated product is going to come out. So here we go. Let's draw in that saturated compound. I've still got the same number of carbons, but what's happened is I've broken the double bond. Remember that in addition reaction, we break the double bond and we add the hydrogen. So that was what was meant. I break the double bond, I make space for the 2 new hydrogens, and they come on the end here. Now see how important the naming is. I can't actually name this thing unless I know my organic reactions. So now there's a reason that they're giving me 3 marks for this, because I had to recognize that this was addition, that my product had to come out as being saturated. Now, they're actually trying to confuse me here. Everything looks the same. And I want you to expect this in your finals. You really got to know your stuff to do multiple choice. Okay, so I've got something right at the end here. If I've got 1, 2, 3 carbons, I get a prefix of prop. So there we go. There's my prefix. So I say prop. Now I look to see how they are bonded together, and I see ane. A-N-E. So propane is my product. So let's take a look and see if we can't see any of our potentials here. Okay, propine is not correct. That's unsaturated. Propane 1-ol. Not right. There's no alcohols inside my product. Propane. That looks pretty good to me. So option C is correct. If you're following with us on Facebook, this example was posted up a little bit earlier, and you can actually follow up on question 3.1 and do this. Discuss this, please. Try and figure out the pattern. 2 reactants became 1 product. That was my first clue. And then what happened was I took an unsaturated and made it into a saturated compound. Okay, so there we go. There's my unsaturated bond. And then I turned it into a saturated compound right at the end there. Okay, so what we're going to do is now we're going to take a look at the other question which I posted online. Okay, and that was 3.2. Okay, now this one is going to require a little bit of explanation. Okay, now I'm going to ask my producer to put this up on the screen because it looks a little bit small to me. I'm hoping that you can read it. I'm going to read it out to you. I hope you can read it online. Okay, so it says during the dehydration. So let's point out some of the key words. They're actually telling us what type of reaction it is. So they're saying during the dehydration, I hope you can read that, of butane 1-ol. And the lucky thing for us is they've actually shown me the structure of butane 2-ol. Okay? Represented below. Compound Y forms as one of the products. So I'm looking for Y, and this is one of the products. That's telling me that there's probably 2. So I know that this thing goes from being whatever it was to being Y plus something else. Okay. Now, I want to make sure that people understand that there's a pattern here as well. I'm going from one thing and I'm making 2 things. I'm going from saturated to going to most likely unsaturated. So let's take a look at these 2 possible products. Okay. Now, I want to know what dehydration is. Dehydration, and it's something that you or I feel, especially on a hot day when we haven't had much water to drink. Dehydration is something that definitely happens to do with water. When you dehydrate, it means to give out or give away too much water. And it's kind of hard to see on this molecule that there is actually water trapped on here. What do I need for water? Well, I need 2 H's and 1 O. Well, if I look on my molecule, I can actually start to take a look and do a little bit of investigation to see where I can get those 2 hydrogen and 1 oxygen. So, let's look at this. I see 1 oxygen over there. There we go, and a hydrogen. What I can do is I can go and steal a hydrogen from there. Now, there's a couple of options over here. I can also go steal the oxygen and the hydrogen over there and go and steal the hydrogen from the middle part. Let me give you a little bit of a tip. Both of those actually happen. The one which is actually preferred by this molecule is going to be the green one, and I'm going to show you why in a moment. Now, I'm going to actually do this twice. I'm going to do once in yellow to show you what the product would be, and I'm going to do it once in green. The reason I'm doing that is actually to show you that there is a pattern to predict which hydrogen it's going to take off. Now, I know that the second product that they said would most likely be water. I know that water would be one of the products. Because it's dehydration, water is the question mark. But now what is the organic molecule which is left behind? Well, if I follow the yellow scheme, if I follow the yellow taking away of water, what I've got is my 4 carbons over there. So 1, 2, 3, 4 carbons. And what I'll notice is that if I keep the H's which were already there, I've got a couple of bonds over there. I had 3 H's on the end one. I had an H and an H. Those were all sitting fine and dandy. They were left alone during this reaction. Okay, but now the big difference was that I was left with only 1 H on this carbon and a double bond. That's quite important. I'm left with a double bond right at the end. Okay, but now if I take off the H and the OH from the middle, what I'm actually going to find is that I'm going to have a double bond in a different place. So there we go. So C, my double bond over there, because my water left from the middle of the compound. Now, I'm going to tell you that C is going to be more likely to make double bonds in the middle of a chain. I'm going to tell you that the green product is actually more likely to form than the yellow. Now, you don't need to know the name of this process, okay? This is called Markovnikov selection, okay, but you don't need to know that. All you need to know is when I'm making a new double bond, it prefers to have friends in the middle of the chain rather than be stuck right at the end. So what I'll find is that my product here, when I'm doing a dehydration, the double bond is more likely to be in the middle of the chain. Okay, I hope people understand that when I do dehydration, I'm taking off my water and I'll make a double bond which comes into the middle of the chain. Now, how did I spot a pattern here? What type of reaction is this? Okay, well, when I'm doing my studying, what we're actually going to do is we're actually going to start taking a look at some of the ways that we can try and predict what's going on. Okay, so earlier on, we started taking a look at addition. Okay, we're going to summarize this together. So addition, how did I figure out the pattern here? I took two reactants, and what did we do to them? We changed them into one product. This is the easiest way to figure out that you've done an addition reaction. Okay, now the really cool thing about this is you can actually figure out what goes on inside an addition. When I do addition, I take something which is unsaturated and I make it into a saturated molecule. Okay, well that's quite cool because that actually tells me some of the clues as to what's happening. So it's going to become saturated, but before that it is unsaturated. That means that it's got double or triple bonds. And then that's going to go to make one product which is going to be saturated because I've added something to it. There we go. So then that's going to become saturated. Okay? Then what happens? Okay, well, addition. That was pretty easy. All that we did was take one molecule and another molecule, put them together. Then in the second example, we did exactly the opposite. The really cool thing is that you can actually figure out that this is the opposite of addition. So now if we remember one thing, we just need to remember that elimination is the exact opposite. So I take one reactant. If you can count, you can actually figure out which type of reaction you've got. So I take one reactant and I change it into two products. That's quite important for you to know. There we go. So I've taken one reactant and changed it into two products. Now, I'm pretty sure that you can guess which one's saturated and which one's unsaturated. If I take one reactant, that's going to be my saturated one. If we take it apart into pieces, it's quite easy to see that if I take a saturated molecule and I do an elimination, I'm doing the exact opposite of an addition reaction. So then that becomes unsaturated. I'm hoping that you can see the patterns there. Okay, now that's the easiest way to tell these two types of reactions apart. Okay, now if we had a lot more time, I'd revise a whole set of reactions, but what I'm showing you is one of the ways that you can simplify your organic studying when you do this at home. Please make sure that you simplify things for yourself and you try and understand the patterns in between there. Okay, so addition was 2 makes 1, elimination makes 1 makes 2, okay, and then if you go take a look at your substitution and esterification, you'll actually notice 2 makes 2. Something along those lines. You can actually figure out from the number and the type of reactants what type of reaction is going to happen. Okay, well, we're going to carry on through those past papers. What I'm going to be doing is running through the third one. During our ad break, what I'm actually going to do is post a whole bunch more of these. I want you to follow. Okay, now we're getting into the chemical change side of things. This is a section which people really struggle. Okay, so what I want you to do is follow through with me very carefully. Don't try to write this down madly. I'm going to post it up online. You can read it there. And I just want you to follow through with me very carefully. Okay, so it's going to come up on your screen there. All right, now this reaction says, consider the following hypothetical reaction. Okay, that just means that it's sort of imaginary. We're not actually doing this experiment. Okay, don't get confused by the big words. Okay, it says that it reached equilibrium. That's quite important. Okay, we were told that it reached equilibrium. That means that the forward and the reverse reactions were happening at the same rate. It says in a closed container at 450 degrees Celsius. Okay, quite important there. Now I'm shown a reaction which I've never seen before because these things are completely imaginary. It tells me that XY, which is a solid, it's quite important that we understand this, goes reversibly into something which is a gas and something which is a solid. There's my two products. So remember my reactants on the left and my products on the right. I'm also told some more information. At the moment, I haven't even begun to take apart the questions. Now, it tells me which one of the following changes will not affect the equilibrium position. Okay, now this is very, very tricky because I'm given a list of things to remember. Now, I've got to be very, very careful about how I actually approach this. Okay, all of these are going to look right. Please be careful. I'm going to read option A, B, C, D out to you, and I'm not going to tell you which one's correct. I want you to sort of think for yourself and try and see what's going on here. Okay, now it tells me an increase in temperature. Well, one of the things that I'm taught very early on is that temperature is one of the main factors in the position of an equilibrium, especially if I'm given a delta H. So I think A might be correct. We're not dead sure. Let's make sure that we cancel out all the other things. Okay, so now option B, it says increase the amount of Y. But now here's the trick. It's a solid. Be very, very cautious of this. Whenever I've got an equilibrium with solids involved, if I change the amount of solid, I actually don't change the position of the equilibrium. Okay, now there's a long and complicated explanation to that, but one of the things that you've got to remember, and this is one of the tricks that they could try spinning on you, is that adding more of a solid is actually not going to change the position of an equilibrium. Okay, now it says decrease the pressure at a constant volume. Okay, now that's going to be quite tricky. Okay, so it says decrease the pressure at a constant volume. Okay, now that's a little bit confusing. What I'll actually notice is that pressure does affect this equilibrium. Okay, but the position of the equilibrium is usually denoted by something called Kc. There's another hint for you guys. Okay, what affects Kc? Then we're told D, something else which actually changes the pressure as well. The clue for me that we can actually cancel out C and D is both of them are actually trying to affect the pressure. They're both trying to do the same thing. Now, it's impossible for both of them to be correct. And also, if I've studied very carefully, I know that the only factor which affects Kc in a closed system, and that's the important thing, in a closed system, the only thing which affects Kc is actually a change in temperature. Okay, very, very important, very, very tricky. I like this question because it forced us to think about everything. What if we change a solid? What if we change the pressure? What if we change the temperature? These are all factors which might affect equilibrium, and they've made them all sound exactly the same. And I'm pretty sure you'll agree that these are very, very tough multiple choice questions. Okay, I think we've got time for one more before we go for an ad break. What do you think?
Do you want to go for a break first and then go through one more?
Absolutely. Okay, well then what I'm going to do is I'm going to post some more of these questions
and
then come back and see how people are doing.
Yes, that'll be great. I know you guys are already answering these multiple choice questions that Phil is putting up. So when he puts more, answer right away. Well, work it out first, obviously, but then answer it and then let us know what your answer is, and then maybe you can get it right. I mean, it's quite exciting when you get it right. See you after the break. Welcome back, Mindsetters. I am loving the interaction on the page, and I'm loving the questions and the answers and helping each other. It's really fantastic to see that some of you who have written the exam and have seen some of these multiple questions that Phil have been doing are actually helping other people answer them. It's fantastic. And now you can also see where you went wrong, because this is not the end. Remember that you also have prelims and finals and all the stuff in between that you need to prepare for. So even if you have written your exam, it's very nice to see some revision and where you could correct yourself. And there are also some more multiple choice questions posted. So maybe you could also work around with them and answer them for the future. Maybe even print them out. That would be fantastic, to actually print them out and see that by the time the prelims comes, you are on the ball with everything. And I also want to remind you about the winter school that will be starting on the 2nd of July, and that you guys can tune in at any point of the day, at any point of the week as well, so that you can see some more revision that will be taking place just on your chemistry. Over to you, Phil.
Okay, well, guys, I've been taking a look at some of the Facebook posts. You guys are going wild on the page. It's fantastic to see. Okay, well, there's going to be more of this on the page. Now, I actually want you guys to help each other to discuss. I actually want you to play around with some of your answers as well, because one of the problems with science is that there's so much information in the question, and it's so difficult for you guys taking notes. You're going mad, and you're busy writing this down. Jump on the page. We're posting these up. You don't have to write them all down. As Katleho says, maybe print them out or check at them on the screens and actually start working with them. And what I'm actually going to do is I'm actually going to let you guys do a little bit of the work and answer some of those multiple choice questions and flesh it out online, because you seem to be coming to some pretty good answers there, and the discussion is amazing. You guys are learning from each other, and that's what this is all about. What I'm going to do now is I'm going to go over to Katleho and see what those sort of questions are about.
Okay, sure. So there's a question by Hope. Hope says, a standard copper zinc electrochemical cell delivers current. How do the concentration of the two electrolytes change as time goes by?
Oh, very good question, Hope. Okay, really, really nice question, because that deals with your chemical change. Okay, so you said a copper and zinc cell. Okay, so let me just do this in terms of what's going on inside a copper zinc cell. So I know that the copper zinc cell is one of those things which lands up in almost every paper. I can tell you every second chem paper that I've seen has got the zinc copper cell inside it. Chemistry examiners love it. So what I'm going to do is I'm going to post up in standard notation what a zinc copper cell is all about. Okay? Basically, a zinc copper cell tells us that I have two pieces. On the left, I'm actually going to tell you that we've got zinc, and zinc is in contact with zinc 2+. And copper 2+ is in contact with copper. And if you go take a look on your page, you'll actually start noticing that this whole thing produces, I think if my memory serves me correctly, that the E0 cell of these two combined is around about 1.1 volts. Now, I'm not magical. I've just done this so many times that I remember this voltage. Now, where does this voltage actually come from? It comes from a reaction between these two. Now, you'll notice that the only way that this reaction can actually take place is because of these guys. Hope is asking me a question about the ions inside there. The ions are what make electrochemistry work. Okay? You've got to have a good concentration of ions. Now she says, what happens, or how is the EMF produced, or the current produced, affected by the concentration of those two ions? So we're talking about, and when I use square brackets, I mean concentration. So the concentration of zinc 2+ and the concentration of copper 2+, how do these actually affect the current which is flowing? Okay, well, one of the really great things is this actually deals directly with redox and the factors which affect the EMF. One of the really cool things I can actually do with this is I can realize is that ions make the current. The more ions there are, the more current can be produced, and the more EMF there will be inside the cell. When you've got a battery or a cell in front of you, when it's going flat, that means that the electrolytes, the ions inside there, are going to a lower concentration. What I'll actually notice is that these two are proportional. Now this little fishy sign, that alpha sign, means directly proportional to the EMF. EMF is the voltage of the cell, and that means that more of the concentration of the ions that I've got, the more EMF and current that I'm going to get out of the cell. So I'll notice that this voltage only works when I've got a concentration of 1 mole per decimeter cubed. That's a standard condition for these cells. That voltage will drop as soon as I'm getting rid of this, as soon as I'm using up my ions, they're going away, my battery's going to get flat and there's not going to be any voltage, no current either. I hope that answers Hope's question.
Yes, it does. And there's a quick one.
Okay.
Lungi asked, does it matter where you place the hydrogen bond? Like, for example, in question 3.2, do you have to put the hydrogen at the top, or can you also put it at the bottom?
Oh, very nice question, Lungi. Okay. Now, in university chemistry, okay, Yes, it kind of does matter, but inside school chemistry, hydrogen on top or on bottom doesn't actually matter. The only reason that I put the hydrogens where they are, they need to be connected to the same carbon. That's one of the things that you're limited to. So this hydrogen over here, the hydrogen on the right-hand side, let's actually highlight the hydrogen that he's probably talking about. This hydrogen could be on the bottom as well. That's okay. It's absolutely fine if it's up at the top, down at the bottom, doesn't really make a difference. It will still be the same compound. Okay, when you start taking a look at more complicated molecules, it actually does make a little bit of a difference, but inside high school chemistry, not a problem. Other carbons, where I could flip the hydrogens as well, over there down at the bottom. Okay, I could flip those and I'd still be correct by metric standards. If you're taking this a little bit further, you've got to be a little bit more careful about those hydrogens. So Lungi, don't stress. As long as it's connected to the right hydrogen, you're going to be fine. You're going to get your marks.
Okay, thank you, Phil.
Okay.
Yeah.
How are we doing for questions? Or we
I think questions are fine. I think that you can carry on with yours.
Absolutely. Okay. All right. So what I wanted to do was actually jump into one more multiple choice and go back to our challenge question and put you guys out of your misery. Okay. So before we left you, I had 3.4 up. Okay, and I'm pretty sure that this is up on the page at the moment. Let me go through this, and this is a little bit of electrochemistry because we know you love redox. Okay, so it says the following characteristics may be used to describe an electrochemical cell. Okay, now please be careful. Electrochemical cells can be galvanic or they can be electrolytic. Now, these two things are very, very different from each other. So let me just highlight those words, and I actually want you to write down the difference between these. Electrolytic is one where I need to put electricity in. Galvanic is one where I get electricity out. So let me repeat that. Electrolytic, I need to put electricity inside. Galvanic, I can get the electricity out. So let's figure out which one of these points applies. The first point, they say, the chemical reaction is self-sustaining. That means that it carries on its own. Okay, well, one of the things that I actually know is that an electrolytic cell needs electricity for that to happen. So that means that point 1 can't be correct. Now, the nice thing about this is this actually limits the options that could be correct. If you know something is wrong and you're absolutely certain about it, you could make your life a little bit easier. So we can go through our multiple choice questions and actually decide that anything which contains point 1 can't be correct. Do this by a process of elimination. We can eliminate anything with a 1 inside it. So that means that option A can't be correct. Option C has also got 1. So that can't be it. Okay, well, let's take a look at our other options now. It says that the reaction requires energy from an electrical source. Okay, well, I've got to see. Is that true for both of these? Well, I'm not entirely sure. Okay? The anode is a positive electrode of the cell. Now we're running into a bit of a problem here, and this is why I like this question so much. So it says the reaction requires energy from an electrical source. Okay, but that sounds like electrolytic. Now, we're struggling here. This is one of the traps that you're going to fall into. The anode is the positive. Now that's only electrolytic. Now I'm a bit stuck. I found that none of these apply. And this is one of the problems that a learner presented to me earlier on. They said, okay, well, I can't just cancel out every one of these. I must have done something wrong. Okay, all right, so let's go back and read our question. We've done something wrong. I want you to figure out what that might be. I can't cancel out everything. There is no option that says that none of this might be correct. Okay, then I start to take a look at my description. Okay, now it says to me, the following characteristics may be used to describe an electrochemical cell. Now, if I've done my studying, I know that an electrochemical cell is actually another word which describes a galvanic cell. So now I need to know that another name for an electrochemical cell is actually galvanic. And that is self-sustaining. Okay, so point 1 then becomes correct if we're only talking about one of these two. The reaction does not require energy from an electrical source. And also, the anode is not positive in this reaction. So I know that point 1 is correct, and that's the only one. That actually leads us back to the one which we tried to cancel out. So that means that option A is the correct one. Please be careful. You've got to know your terminology. Everyone I know got stuck on this. They said, okay, well, electrochemical cell. It might be either one of these. What they're trying to see is if you understand that an electrochemical cell is another way of saying a galvanic cell. Electrolytic is the opposite of an electrochemical or a galvanic cell. There's lots of these examples. Very, very tricky one. I know that only a few of my matrics actually managed to get this last year. Okay, what we're going to do is we're going to put some people out of their misery. We're going to try and see how that challenge question came out, and we're going to try and see if people got to it in the correct method. I don't know how people are doing on that challenge question on the page.
Let me check it out.
How's it looking? Okay. So I think we've got a little bit of time to actually figure out what's going on here. Most of you managed to figure out some of these. I'm pretty sure that most people got X and Y. Okay, so chemical Y was the place where we started our reaction. Okay, and I did electrolysis. Most of you figured out, I'm fairly sure, that I started out with NaCl. So that is chemical Y. Okay, chemical X was one of the products which came out. And it was one of 3 products which comes out of the chlor-alkali process. Okay? So if I do electrolysis on NaCl, the only thing which I don't see in here anymore is Cl2. And that is chlorine gas. Okay. That leaves us only with option Z. Okay, well, option Z was a very tricky one. I wanted to actually figure out what was joining onto option Z. And I'm pretty sure a whole bunch of you figured out that there's something missing. Okay? So option Z, what I've got to realize is that there's actually 3 chlorines on here. And that's a bit of a clue. If I've added on Cl2 and there's 3, there must have been 1 there before. Okay, so option Z, what we're going to do is we're going to draw it out, and I'm going to give you the name, and then we're going to actually see who managed to get this right. Okay, so there must have actually been one of those chlorines on before. So let's draw it out. So I've got my 3 carbons over there. So, sorry, 2 carbons. I'm corrected here. But what I'll find is that that initial molecule had to be unsaturated because this was an addition reaction, and one of those must be a chlorine. So what you'll actually find is that there is chloroethene. So just check your answers here. Okay, so starting on the right-hand side here, I've got option Y, which is NaCl. Okay, and that was a starting basis for electrolysis. And the way that I figured this out was that I knew that electrolysis was part of the chlor-alkali process. So there we go, if you're looking for a place to figure out that, and if you're practicing a little bit of redox there, that is the chlor-alkali process. So I electrolyze, or I undergo electrolysis of chlorine and sodium ions, and that becomes my 3 products. So I'm going to make the chlorine, which comes out here. There we go, chlorine is my 1 product. I've got hydrogen as the other and sodium hydroxide. Just a reminder, these tiny little details, you need to know them. You need to know the 3 products. I need to know that chlorine is used to make pool products. It's used to make plastics. Hydrogen is used to make margarine. It's used to make a whole bunch of petrochemicals. Sodium hydroxide is used in soap and paper production. See how it's rolling off my tongue? Except when I do that, okay? So you need to know this, guys. Absolutely important that you know how to use every single one of these. They're going to ask you the specifics. Okay, now back to this guy. This guy was particularly tricky. I knew that 2 things were making 1, and that was an indication that what we were doing was actually addition. So there we go, addition. Let's write that in for you guys. If I'm doing an addition reaction, that means that I need to start off with an unsaturated compound, and that's where the double bond came from. And also, and this was a real trick, this was really mean and nasty, what I actually managed to do was to put in 3 chlorines, which was a little bit confusing. I think we're going to leave people to discuss that on the page further. I think that's it from me for tonight.
Okay, awesome. Well done, guys. And well done for all the questions that you got right and everything that you were doing on the page. It was fantastic to see that most of you matrics are really understanding what is going on. And as I said, even if you have written, you know that there are many more exams this year for you guys to clear up on. So by the time you get to your finals, oh my goodness, you'll be getting A's. Remember that there's also a Saturday lesson, a live show on Saturday for you guys to tune into for anything that you didn't understand now, anything that you think perhaps didn't actually go through. So remember that we have that going as well. See you next week for more Learn Extra. Bye, guys.